Good evening, everybody. I'm Kalyan, and I have the illustrious Professor Venkatesh with me. We're going to be talking a lot about brain aging and blood biomarkers. And before I start, I just want to ask a question here. How many of you guys here actually care about your brain age? You actually care about your brain age? Okay. How many of you know what your brain age is? Do you guys have a number? How many of you know this number? Okay, good. So we're going to talk a little bit about this. These are actually paradoxes, as practitioners broadly in this field that we see. A very brief introduction about me. My name is Kalyan. I run a company called 5C. I'm actually much more in the imaging space. We build AI in radiology, and we're building an AI radiologist. I'll quickly hand it over to Professor Venkatesh, the illustrious Professor Venkatesh, as I said, and then I'll directly jump into some hard-hitting questions because the nation wants to know, Professor.
Yeah. So you're going to corner me. So I'm a chemical engineer. Again, I think none of us have been trained full-time either as physiologists or biologists. So I'm a chemical engineer, but I've been working in systems biology. And about 8 years back, I started using systems biology in a company that I started, Netflix Research, where what I thought was, there is no platform where the fragmented biological knowledge has to be available, digitally, which is benchmarked with the data that is available, so that physiological assessments can be had, and one can use this as a platform where knowledge and data, validated data, are available for analysis. So that is how the biomarkers that we are going to talk about get sort of fitted in the kind of platforms that we're building.
Fantastic. So I'm going to start actually with a very quick rapid fire question for you. This is a googly. On stage here, talking about some very, very important biological work, is a computer science engineer and a chemical engineer. And there is no doctor on stage. The last time I was on stage at IISc, I was giving the keynote at the Association of Healthcare Providers of India conference, where the room was full of doctors. There are almost none here. Is longevity a part of medicine that is out of the doctor's preview? 30 seconds or less.
No, I think finally, wellness or a disease management has to go clinically.
Yep.
So the doctors have to interface.
Sure.
Okay. Although they may not be on the stage today, but it has to be interfaced through them, and neither the AI or the engineers can sort of communicate. What has to be communicated, it has to go through clinicians, is what I believe.
Agree. Shout out to Longevity India for always keeping clinicians in the loop. As we're talking about brain age, I want to ask you a slightly more meta question. And for you, people who go down YouTube rabbit holes, you guys may vibe with me on this. There's a very interesting video of a guy called Rory Sutherland. He is the head of Ogilvy and Mather. And he talks about how one of the projects that he had was to try to solve range anxiety for EVs. And people who have EVs here, I'm sure you have felt it. And he said that one of the reasons you get range anxiety is because that thing actually tells you 87%, 42%, 29%. You're seeing it fall and you get anxious. But if you look at even a petrol car, you have like 6 bars. And it goes, and you broadly know where it is, and actually it's a lot more comforting. Now, when I ask people here, who cares about their brain age, I'm sure everybody here thought of it as a number, And so I first want to ask you, is brain age is a number that is brain age even important? Or should we much more be talking about it as, hey man, you're okay, or you're not so okay, or you really need intervention? Is there really a number that is important in brain age?
Yeah. So most of the quantification, right? I mean, even pathophysiologically, you would either say, oh, something is very severe, something is moderate or mild, or healthy, right? So these are the typical benchmarking that is sort of given. Although in a report, you have numbers and you say, oh, these are the healthy range,
sure,
right? But finally, when an assessment is done, it is more in terms of, degrees, right?
Sure.
In terms of that. So that is what I would, consider as like what you were also indicating, bars rather than giving an exact number. So that the purpose is served. It is what
it's actually a big, a topic with one of our partners, Biopeak. We've been building a lot of stuff around brain age, and of course, the whole point is you have no baseline on which to build upon. And for a person of chronological age of 45, what does 43 mean? If you have a brain age of 29, is that a good thing or a bad thing? Is this just a Twitter flex, like a Brian Johnson flex, or is there something much more clinical towards these numbers that we're giving out?
Yeah. So very difficult to answer because, in terms of numbers, you look at the complexity of the system itself, right? Telling them 43 or 42, doesn't make much sense.
Absolutely.
But finally, it is how an individual perceives it. And if the individual wants a number, fine. You get a metric and give him a number. Otherwise, I think broad, scoring is good enough.
Perfect. So before I ask you the next question, Prof, I just want to give 3 definitions so that we're all on the same page. Chronological age, time elapsed, how long you've been alive on this earth. Biological age is a model-derived estimate of the physiological state or future risk relative to peers. And finally, brain aging, as we would define it, is the accumulation of structural, vascular, molecular, and functional changes in the brain. So now that we're clear on the definition, Prof, my question for you, we've had eminent speakers right before us speaking about biomarkers. Of course, the people who literally discovered tau 217 were right before us. How are biomarkers and physiology actually linked? And your work is on thinking through an engineering perspective. So tell me how biomarkers like tau 217 and physiology are actually linked.
Yeah, so essentially because of the tech that is available now, one can map the existing knowledge with certain confidence.
Sure.
Okay. And you can overlay the data, right, on the knowledge that is there. So you have a validated knowledge and you have a validated data set. Mm-hmm. Okay. If you just take data by itself and then say, I'm going to analyze it without the layering of the network or the knowledge that exists, right, you're missing that sort of constraint that the knowledge puts in mm-hmm. on those numbers that are aligned, especially in a complex assessment. So we are sort of building platforms where the knowledge is structured. Mm-hmm. When I say knowledge, right from triggers to multimodal data mm-hmm. to different organs, which are the processes and pathways which are perturbed. Mm-hmm. And can I give a definition of a state mm-hmm. of a particular organ given a set of biomarkers that are present?
Sure.
Right? So I'll just take this to show some of the networks or what the level of complexity is that we want to now link biomarkers
sure.
to a particular physiological state. So I just quickly got through our platform, how do I link lifestyle triggers to brain aging sort of phenotypes, okay? So I'll get some 120 lifestyle triggers, right? Which gives me various triggers which leads to brain aging. So you have high blood pressure, physical inactivity, air pollution, salt intake, nap during the day. So all these are scientifically linked to brain
Is nap during the day
aging.
Good or bad, Doc?
Huh?
Is nap during the day good or bad?
It's good.
Okay.
Yeah. So
for all those who are sleeping here, not bad. Okay.
so now you have organs and systems which are linked. Then you have biomarkers. So you have scientifically 320 biomarkers are linked to brain aging, and we link it to all the references where we have picked it up. So you have 320 markers, which now we can assess that which processes and pathways they are perturbed, which are close to 1200 processes and which are perturbed, leading to specific symptoms and phenotype. Okay, so if I want to define a brain aging, so this is I'm not showing you the linkages, but obviously these are all linked with a knowledge graph. That is what we build. So you need to validate this knowledge and overlay the data on that. Those 320 markers I have to overlay on the top of this. That is when I can now say that, oh, this is your biological age, right? Or this is your brain age. right? So by assessing and then defining what is the state that you have. So to do this at a complex level, you have to capture knowledge, validate that. You have to capture data, validate on the top of that, okay? And you should have assessment that you can do, okay? Can I subgroup it? Can I cluster on them, right? And find out which are the pathways, which are subgroups, right? So I have to cluster and then put that. Only then I can say, okay, I've understood this, and with a lot of
So you're
information
using,
which is unknown.
you're also using a lot of terms without using the word AI, because we have heard too much AI in our world.
Yeah.
So you said clustering. If I get all that information and I'm just throwing it into, ChatGPT or Claude that now has 1 million, token context window, is it going to do the job, or, is there a more responsible and a more scientific and a more proven way of thinking through this? Is there something neurosymbolic here? Talk to me about that.
Yeah. So essentially what we are doing is we are doing with the validated knowledge graphs, not from the general LLMs that are available. We may use LLMs,
Sure.
but to generate a graph, but it is also human validated, because we want exact knowledge has to be captured in a particular way where questioning can happen, analysis can happen, right? Say for example, you want to know, and we have talked about cortisol, right, a lot. And cortisol, 8 a.m. is measured, then it goes down, then comes up. So you have a circadian rhythm change, right? So you have so many interactions. Just one measurement, one biomarker is telling you so many things can get perturbed, right? So, but in an individual, what does that mean? That perturbation in cortisol, what does it mean when you have this level of complexity? You have positive correlations, you have negative correlations, you have feedbacks, you have plasticity, you have bistability here, right? Adaptive response. All this is embedded in this network. And now you're saying, I measure cortisol, and how can I tell what is the physiological state that you have? So, okay, I can do gut microbiome. We have been speaking about that. I'll put that constraint on this network, okay? What is gut microbiome telling in terms of these network getting perturbed? Okay, I'll measure lipids. I'll start measuring, genome bias, right? When I start putting several constraints along with the cortisol, then I'm personalizing, or I'm giving more and more evidences,
Sure.
right? So typically it's very difficult to say digital twin because we don't understand completely. The only thing that we can say is the totality of evidence. What is the totality of evidence that I can give, given a biomarker measurement and the knowledge that exists, okay? Which has come from illustrious research of so many, leading scientists, right? So given that knowledge and given these biomarkers, what is the best way that I can say this is the totality of evidence, right? So what is the best that we can do at this stage, given triggers, pathways getting perturbed, and converging on a certain totality of evidence. So I remember Sherlock Holmes' one statement,
Sure.
I think it is from 4 Seasons, where it says that if I remove all the improbables, whatever remaining is the truth.
Sure, absolutely.
Because, you have removed all the improbables.
Correct.
However improbable it may seem,
It is
that,
the truth.
that is the truth, okay? It's the same philosophy that we're putting here, trying to get all the knowledge, get it validated. Now say these are all the multimodal data. I have genomics, I have epigenetics, I have gut microbiome, blood markers, urine markers, omics data, right? I will overlay on the top of a particular physiological state and now say what is the totality of evidence, okay? Given these constraints, what is the best that I can tell about the individual or about any cohort studies that I'm doing?
Sure.
What is the best assessment that I can do?
Sure.
Right? So that is the philosophy that we are taking to bring systems biology approach by bringing knowledge and data and analysis together on one digital platform.
So on the same note, Prof, when I started the session, so many people raised their hands and said they want to know about their brain age. So technically, that means that there is technically some kind of market demand for a screening test. Now, my worry with screening tests as somebody who's built a lot of AI in this space and built a lot of tech in this space is that, let's say you have even a precision and recall of 90% each, but you have a very small disease burden, let's say 10 in 1,000, then you will have with given those metrics, you'll have 90 true positives and you'll have 90 false positives, which means that your positive predictive value of such a test is literally 50%. That is a totally useless screening test. So is there a pathway for the science that has been developed so far to actually become a valid screening test so that all these people who have raised their hands actually get what they want? Where is the science and where is the math on that?
So for some diseases, okay, which are tractable in terms of the processes which have got perturbed,
Sure.
okay, one can do some analysis of this kind. Okay, liver is one of them. Okay, so you for example, fatty liver.
Sure.
Right? Even that was getting discussed in
Sure.
the previous sessions. You can get the liver enzyme ratios, right? You can get GGT, HOMA-IR, and then you say, this is the fatty liver score.
Sure.
Okay, but if I build a network of this kind, it will say that 76 markers have been linked to the pathophysiology.
Sure.
Okay? But clinically, you are using only 7 or 8. So, what is this other 76? Okay, where studies have sort of indicated. Okay, that's what the knowledge and the data is suggesting. So, how do you use the remaining? Right? So, clinically, you have used some 7 or 8 markers to say, this is a fatty liver. Okay. So, what is that optimal number that I have to, do the measurements?
How many
and get
times
the
do you have,
confidence?
how many times do you think you have to do those measurements? Like, what is the minimum number of times that you feel these measurements have to be done?
So if it is a very precise state that you are defining at, obviously with even one measurement you can align.
Sure.
But there are where you need to see how the progression is happening. So then there are multiple time points also are needed.
Sure.
Okay. And even the biomarkers linkages could be, dynamic. Like
Sure.
cortisol, the example that I'm giving. Instead of just giving at 8 a.m., if you give me multiple time points during the day, I will have better assessment that I can do. Just by having one time point, I may not be able to be precise, predictions that are possible. Right?
Perfect.
So it is all constraining in terms of what is available and how we integrate the knowledge and data to give a assessment.
I think they're telling us that their brains are aging because of our conversation. But I'm going to ask you one last one, Prof. So from my domain of imaging, the golden test even today for brain aging is, let's say, an amyloid PET or some kind of MRI. Now, recently, of course, as the distinguished speaker before us was talking about, there's now FDA approval, but which has categorically said that for blood to replace imaging, you need a precision and a recall of over 90%. Now, even if you go behind blood, there are now these, you're seeing cognitive tests. I think my friend Isaac is somewhere here who's running Ivory, doing some very interesting work. There are a couple of guys from Temple here. There are these tests even before blood. Are you seeing that there is value in a totally multimodal integrated approach? Or do we need to go towards pure precision and just stick to blood and imaging? Or is there value in all this? What's your thought there?
Yeah. So as I was indicating, right? So as I was indicating, the multimodality, you need to consider all the possible states, okay, to constrain to get, including what the symptoms that the individual itself is facing,
Yep.
or some of these tests are evaluating. Okay. For example, even sleep quality. Okay. You cannot ask an individual and say, "What is your sleep quality?" Right? So it has to be either measured,
Sure.
or when he wakes up, he has a feeling.
Sure.
Right? Did I get a good sleep? Or it's full of dream, right? So those inputs are very crucial because they become our, constraints that I'm going to put.
Got it.
So I think blood markers are obviously quantitative, and then you have numbers associated with it.
And it's deep science, so it's
It is
fantastic.
all deep science. And then you have genomic, your GWAS data, statistics, right? So you link them and put a constraint. So this is also a input that you're providing, your triggers and symptoms to constrain the network and to give evidence that what is the state that individual is in.
Perfect. So I think, to quickly conclude, the tests in blood are getting better, but maybe give people a broad indication rather than give them an exact number on brain age.
Sure.
Fantastic. We'll conclude on that. Thanks, everybody.
Yeah. Thank you.